The last little bit of 6.3 has to do with the one-to-one property for exponents. And we're going to use this to be able to solve some simple equations. Some of them are a bit complicated, but we're going to use the one-to-one property of exponents, which says that if I have the same base raised to two different powers, then that means that those powers have to be equal to each other. So if a to the m equals a to the n, then m has to equal n. Here's an example of that. If 7 to the x equals 7 to the third, then I can automatically say that x has to equal 3. And that's that. That's all we're doing on this one. This one asks us to take a step further. See how the bases are not the same, but we can make them be the same. So I will keep this as 5 to the x plus 3, and I'll use what I remember about negative exponents to say that if I have 1 over 5, that's going to equal 5 to the negative first. So that was like, well, they used m's and n's before. A to the m is equal to 1 over a to the negative m, and a to the negative m equals 1 over a to the m. So we can change the location of that base by raising it to a negative exponent. So here I had 1 over 5. I rewrote it as 5 to the negative 1. Well, now I have the property of exponents, the one-to-one property, where I have the same base equal to each other, which means that those two exponents have to be equal. So then solving that gives me x equals negative 4. All right, 1 over 5 to the x equals 1 over 25. So in this case, I don't need to rewrite this with negative exponents. I can keep it 1/5 to the x. And then I can think about 25 as being 5 squared, which means that 1 over 25 would be 1 over 5 squared. So I can rewrite 1 over 25 as 1/5 squared. And that automatically takes me back to that one-to-one property of exponents so that I can say x equals 2. All right, so we're looking again to try and make our bases the same. I can't make 5 into 125, but I can remember that 125 is 5 cubed. So I'm going to have 5 to the power of x squared plus 8 equals 5 cubed to the power of 2x. Remembering that when I raise a power to a power, I multiply the exponents. So now I have 5 to the power of x squared plus 8 equals 5 to the power of 6x. And now the one-to-one property of exponents applies because I have same bases. So I've got x squared plus 8 equals 6x. And solving this would be x squared minus 6x plus 8 equals 0. Which factors to be x minus, just kidding, x minus 4 times x minus 2 equals 0. The solution to that equation will be x equals 4 or x equals 2. And since there are no domain restrictions on exponential functions, that will just straight up be our answer. All right, 8 to the power of x plus 4, or excuse me, that's a negative x plus 4, equals 16 to the power of x. Now, unlike all of these other ones, I can't change an 8 into a 16, and I can't change a 16 into an 8. But what I can do is I can change both the 16 and the 8 into powers of 2. So I remember that 8 is 2 cubed and 16 is 2 to the 4th. So I'm going to rewrite both with a base of 2. Because that's my goal, is to get those bases to be the same so I can use that one-to-one property of exponents. So I'll rewrite 8 as 2 cubed, and I'll rewrite 16 as 2 to the 4th. Then I still have the 8 is raised to the power of negative x plus 4, and the 16 is raised to the power of x. Remember what we just saw is that if I raise a power to a power, I multiply those exponents. So then I have 2 to the power of negative 3x plus 12 equals 2 to the power of 4x. And just like that, we have the one-to-one property. So we've got negative 3x plus 12 equals 4x, or 12 equals 7x. So x would be 12 divided by 7. Okay. Last one. Now this one is different because we kind of have like 3 separate chunks, and we've only had 2 chunks on the other ones. What I'm seeing so far is that here I have a power to a power, which means I can multiply those exponents. So I have e to the 4x times e to the x squared equals e to the 12. I'm thinking back to my properties of exponents here, another properties of exponents, which is that if I have 2 bases, 2 of the same base multiplied, then I can combine those into one base by adding the exponents. Kind of like, remember, if I have x squared times x to the 5th would give me x to the 7th, like that. So I can rewrite this part with these 2 bases as a single base by adding their exponents. So e to the power of 4x plus x squared would equal e to the 12th. And that is a one-to-one property. So I can write 4x plus x squared equals 12. Subtracting that 12 over and rewriting in standard form gives me x squared plus 4x minus 12 equals 0, which factors to x plus 6 times x minus 2. So my solutions would be x equals negative 6 and x equals 2. And again, there's no domain restrictions, so that would be my solution.